All right, I'm going to go ahead and get started. Thanks everybody for hanging around for this late session here. My name is Michael Merideth. I'm the Senior Director of IT for VictorOps out of Boulder, Colorado, and I'm going to be talking about the open source monitoring landscape. Since the 90s now, there's been a sharp division in tools and methodology between the enterprise space, startup, and small business communities. Obviously, smaller businesses, especially in the tech sector, were early and eager adopters of open source technology and much quicker to learn to rely on open source tool chains in business critical applications. Up at the enterprise level, of course, at the public companies, they're only now fully embracing Linux as a business critical tool, and I think that's largely because the enterprise is starting to be defined by companies that either came up in the .com era, like Google, or built the .com era like Sun or Dell or, let's say, Red Hat. So the enterprise had their tool chain built on commercial solutions like HPUX and OpenView and so on. And the startup community, the .com community, had a completely different tool chain based on Linux, based on open standards and protocols, and built with open source components like GNU and Apache, ISC bind, and so on. I'm lucky enough that I've been able to spend my career in the startup sphere working with that open source tool chain. I started working in IT in the mid-90s in the Colorado Front Range, and I've spent my time since then working for and consulting at early stage startups and other non-enterprise shops. I've been able to see firsthand as the OSS tool chain has gone from kind of seat of the pants flying to mature, stable, mission critical solutions, of course with the seat of the pants mode still available if you want it. I've always been interested in monitoring and telemetry and the ways it can help make life easier for people like me. So I really have my dream job right now working for VictorOps in Boulder, Colorado. We spend a lot of time integrating our product with monitoring tools, which gives me an opportunity to see a lot of what's out there and hear from our customers about what they're using and how it's working for them. So that's why I'm here to talk to you about open source monitoring today. When I started in IT, the free monitoring options were a little thin on the ground, and most of us were running scripts out of cron and using other homegrown solutions to get the job done. There you can see a screenshot of Big Brother, which was a common OSS tool at the time. Isn't that nice? I love the grid, which assumes that every host is going to be running every service. That's just good design right there. In the late 90s, better open source monitoring tools started to emerge and get adopted. And for several years after that, not much changed. A great deal has been happening in the monitoring space lately, though. I think it's in response to the rise of virtualization and cloud hosting, and in response to the rise of DevOps business methodologies. Some older, more established solutions are making changes or getting challenged by new approaches, and I think a line is being drawn between a more enterprise-like all-in-one approach to monitoring solutions and a more modular approach. There's three main categories of monitoring where I'm going to be concentrating my focus here. First is traditional functional monitoring, and that's the type of product that pages you when your website goes down. And Nagios is an obvious example of a functional monitoring product. Then we have time series data collection, where we're more frequently generating graphs than generating alerts, though there certainly can be overlap. Cacti and Graphite are good examples of that. And finally, we have event processing, where we're looking at log content and other log type events, and this might get visualized like time series data, or it might generate an alert like a functional monitoring system. And Logstash is a good example in this category. So you can see there's a lot of overlap to these categories, and most organizations are using a combination of all three. I'll be examining some projects that take on a single category here, and a few that attempt a broader scope. First, though, I want to talk about why open source monitoring is so important. Business methodologies are changing from the ground up. I don't know about you, but the day-to-day practice of my job looks radically different than it did 5 years ago. DevOps, systems management frameworks, and infrastructure as code change the picture of how I want my management tools to work together. Virtualization and cloud hosting means that network architectures have been changing as well, and the definition of on-premise is evolving. But what hasn't changed is the absolute requirement of availability. That means failure detection, that means capacity planning, that means predictive analysis, all while working at elastic scale. So proprietary tools have a tough time in this environment. Maybe the licensing model doesn't work with a constantly changing network size, or maybe it isn't realistic about multi-site setups. Availability of the features of the software itself becomes a premium feature, and maybe something about the product makes architecture demands that you simply can't meet. And of course, commercial solutions are frequently not excited about integrating with competitors' products. So the commercial tool becomes a constraining force in the DevOps workflow, and you either lose velocity because of it, or you limit your use of the tool and you pay a price in quality. Open source tools tend to integrate more easily with systems management frameworks like Puppet and Chef, as well as with other monitoring tools. They can be deployed experimentally without making a big financial commitment. And you don't have to worry about return on investment if you only want to use a subset of some project's features. So, open source tools can become a process accelerator rather than getting in the way. And what about SaaS? There's a ton of new software as a service offerings in the monitoring space. And at VictorOps, we're happy to work with them all, of course, and they can provide great point solutions, especially in the early product development stages. I'm also a big fan of using external monitoring services to provide a second line of defense in case your primary monitoring solution fails. And they can also be a great way to see how you're performing from different parts of the world, and that's obviously difficult to do for yourself. However, they tend to be priced by the data point. So as you scale up, you tend to wind up going from watching everything to watching a statistically significant sample to watching a statistically insignificant sample, and it's the same problem as enterprise software. You under-monitor, you sacrifice quality. So if you're scaling up at all, you can use managed services, but you're still going to want on-premise solutions that you can scale at will. All right, so let's start looking at the open source tools that are out there, starting with functional monitoring. This isn't a comprehensive list of every project out there, so your personal favorite might not be represented, but there are some projects here that I thought were interesting or important for one reason or another. Nagios, of course, for about 15 years now, the 500-pound gorilla of open source monitoring has been Nagios. It is the most commonly used integration we see at VictorOps by a wide margin. When it came along, most of us were using Big Brother for monitoring, like I showed you on the earlier slide, and homegrown scripts were running out of cron. In that world, Nagios was a revelation. Its strength is that it's really just a scheduler and an event handler, and all the complicated check work is done by a highly modular and portable system of plugins. It's easy to write a check plugin for Nagios, and given that the checks are standalone programs that are called with a fork and exec, the plugins can easily be reused by other monitoring daemons like NRPE or by completely different solutions. Plugins have been written to do complex, deep monitoring of most devices and applications out there, and it's a thriving ecosystem. The configuration language for Nagios is well understood, even though it can lead to some ambiguity, and it's possible for Nagios configurations to get really complex. It mainly has the advantage of having been ubiquitous for so long that virtually everybody in the industry has some experience with Nagios configs. Systems management tools like Puppet have built-in capabilities for generating Nagios configuration, so it's relatively easy to build a configuration that automatically picks up changes in your network architecture, for example. And again, it's extremely flexible and can be adapted for a lot of different use cases. On the other hand, Nagios is not without its critics. Again, Nagios Core is a relatively simple piece of software. It schedules checks, it parses the output, maybe takes action, has a basic web interface. It doesn't generate graphs or track metrics without add-on software. It doesn't parse log files or deal with event streams. It doesn't do automatic discovery. Now, these are all true, but these are all kind of intentional choices made by Ethan Gallstad and Nagios Enterprises. And that's built into the architecture, and it's part of the reason why it's so modular and flexible and relatively good at what it does. But there are some more general and kind of legitimate complaints. The web interface is clunky and dated and hasn't been changed substantially in years. Nagios version 3, which is the version that's in widest use right now and is in the repos of most of the major Linux distributions, is a bit of a resource hog, and it has trouble scaling past a few thousand data points. It's not cluster aware, it's not designed for high availability, it doesn't lend itself well to multi-data center use or horizontal scaling. Those are things that are all possible, but pretty difficult with Nagios. The configuration language is well known, but widely criticized, and I think rightly so, for being ambiguous and confusing. There's 3 or 4 ways of doing everything in Nagios config, and if you've got a bunch of people working on your Nagios config, you'll find a combination of all of those eventually. It kind of gets crufty over time. The add-on ecosystem has addressed a lot of the complaints, but there is growing dissatisfaction in the community about the pace of development and the core Nagios project, and the fact that Ethan Gallstad, the original developer and CEO of Nagios Enterprises, was acting as a sole gatekeeper for the changes to the core code base. Some people in the community had different ideas about product scope and what features should be included, and others had different ideas about the overall product architecture. In 2009, over 10 years after Nagios' original release as NetSaint, a group of developers announced a fork of the Nagios project called iSinga, and that's been gaining in popularity ever since. More recently, the Shinken and Namon projects have appeared as well. All 4 of the projects have taken radically different views on design, architecture, scope, and monetization strategy, I should mention. Now, as with all software projects where human developers and human egos are involved, there's been no shortage of digital ink spilled about the political controversy surrounding the forks, and there have been critical statements made by all the parties about one another. That's well covered online, so I'm not going to wade into it here, and read all the accounts before you form an opinion. That's my advice. The only opinion I have is about whether the controversy affects me personally, and no, it doesn't. It doesn't affect whether or not I would use any of these projects. As a user of open source software, I think the forking of Nagios has been a big positive. iSinga version 1 brought a lot of long-needed improvements to the web UI and added support for additional database backends, among other things. At the same time, it's motivated Nagios to add more developers to the core project and to quicken the pace of development. So the users of both projects have benefited. I think we'll need to wait and see what the ultimate impact will be of Shinken and Namon, but I expect they'll have similar effects as well. There are big changes happening right now. Both Nagios and iSinga introduced new versions in 2014 that put them on a wildly divergent path. Nagios 4 and iSinga 2 are both major rewrites, with iSinga 2 going so far as to adopt a new configuration language. If iSinga was perceived as Nagios with a nicer UI before, it's now a substantially different product with different design and architecture goals. So iSinga 2, again, it's a complete ground-up rewrite. It provides a new CLI management interface with access to program and monitoring configuration objects. Several common add-on features like database integration and performance data collection are now built-in modules that can be enabled or disabled as desired from the CLI. It includes several performance features, including the ability to reload configuration data without interrupting running checks. And if you work in a shop that updates Nagios config a lot, you know that that's a big deal. The configuration language is completely changed from the Nagios standard. They do include a tool for converting Nagios format configs to the new format. The config language is said to adopt a one best way design philosophy with the idea of eliminating the ambiguity that can arise in a Nagios configuration. It's object-oriented and rule-driven, which means that after initial templates are defined, managing changes in the config should be pretty simple. I personally really love the look of iSinga 2. We're piloting it at VictorOps right now, and we may be adopting it for production use later this year. And here's a screenshot of iSinga 2. This is the iSinga Web 2 interface that they put in front of it. They also have a more classic-looking web interface. But you can see that this is a much more modern-looking interface than Nagios. But the design is just part of it. They've made relatively minor changes to the way you interact with multiple services or multiple hosts at a time that have produced big productivity gains over the Nagios UI. Nagios 4, though, is also a major rewrite, obviously sticking much more closely to the original Nagios paradigm. Nagios Core now spawns lightweight worker processes that handle check execution, and that has greatly increased efficiency. Nagios has also made improvements in APIs and event handling, and they've obsoleted some features that were never fully implemented, like failure prediction, or that had become difficult to maintain, like the embedded Perl interpreter that nobody used anyway. Nagios has also added new developers to the Nagios core team, and a succession strategy has been worked out. So they've signaled that they intend to increase the pace of development on the core product and also integrate more changes that the community has been asking for. The nice thing about Nagios 4 is that it accomplishes all this while maintaining configuration fidelity. And in fact, the day-to-day operation of Nagios 4 is essentially unchanged from earlier versions. This means that if you're using Puppet to manage your Nagios configuration, for example, you can upgrade to Nagios 4 pretty much in place and enjoy the performance and benefits without a ton of work. On the downside, the web UI still hasn't significantly changed from Nagios 3 and is starting to feel really dated. Lots of common tasks are tedious and difficult from the UI. They've changed the default look and feel from black to white, and you can see there. So it's a more readable interface, but it's still frames and tables. Shinken aims to have it both ways, being a complete reimplementation of Nagios core as a series of modular Python-based processes, but that maintains legacy Nagios configuration compatibility. And they boast very impressive performance numbers and an architecture that provides for high availability and high scale. That comes at the cost of having a lot of moving parts and a lot of external dependencies. It's also distributed through the pip packaging system, which I'm not a huge fan of. And then it has its own internal package repository-like functionality for adding modules to the software. So if you like the idea of layers upon layers of package managers and interdependencies, then Shinken might be a good fit for you. There's also a commercial Shinken Enterprise product, which includes some additional features not included in the Community Edition. So if you like the idea of paying for external dependencies and layers upon layers of package managers, then be sure and check that out. Finally, I'll mention Nemon, which is a more recent fork. This one is a fork of the Nagios 4 codebase. And the goal of the project is to introduce some of the same community-driven feature requests that Isinga and Shinken do, but also with an explicit goal to have a non-commercial entity managing the project and ensuring an inclusive development process. So if you find that the politics around using Nagios or Isinga or Shinken bother you, then Nemon might be a good choice. They just hit their 1.0 release a little over a week ago, so the project is just really getting going. I couldn't even put a logo up for them because they don't have one yet. So if you are looking for an opportunity to contribute or participate in an open source monitoring project, it seems like there's a lot of opportunity there. There are some commercial Nagios derivatives as well. There's Groundwork and OpsView and others, I'm sure. I don't see a lot of value in them. They really don't offer anything over Nagios core except a visual cruft and a licensing fee. And if you want to pay to run Nagios, then you can certainly pay Nagios to run Nagios. There are a couple of other projects that I'll mention that are focused on functional monitoring. Sensu is a good example. It has a fairly similar scope and feature set to Nagios, but takes the form of a composable framework of components, including a web interface that can serve as a front end for several Sensu servers. Like Shinken, it has a lot of external dependencies, and getting it up and running is no joke. But if you need extreme flexibility and have any specific architectural requirements, it might be for you. At VictorOps, we're seeing a growing number of our customers that are using Sensu, so I expect to see the popularity of that project to continue to grow. Monet is kind of a completely different thing. It runs as an agent on each monitored host. It can be configured to watch processes, files, or other metrics, and take either scripted actions or throw out an alert when thresholds get crossed. Monet provides a lightweight web interface for looking at status and statistics, and a commercial product called Monet or I don't know, can provide a central management point for several hosts running Monets, but it's not a required component. In a managed environment, I think you might use it to send events to a Nagios host or a Sensu host, and in that way decrease the polar load or avoid having some of the security concerns that you might get if you were running NRPE, for example. All of the solutions that I just mentioned are great if you are in a DevOps workflow like I am, and you have a managed infrastructure. using something like Puppet or Chef. The hosts and resources that get monitored are either defined in well-known standard text configuration files or can be managed programmatically. So it's possible to wire them into your systems management framework and get your configuration auto-generated. Of course, not everybody lives in that world. Auto-discovery is an important feature for a lot of shops, and if you work for a larger company that's making acquisitions, you might find yourself managing an inherited infrastructure with little prior knowledge and poor documentation. I've certainly been in that situation where my company acquired a company and the IT team headed for the exit before I even got a chance to talk to them. So it was like, here's your data center, good luck. And auto-discovery can really help generate documentation and really help you get to know a new environment. It can also act as a network tripwire, detecting devices that may have been placed on your network without your knowledge. Most monitoring systems with auto-discovery can set a notification when a new device is discovered. So that can be helpful if you're worried about network security. OpenNMS is an example of a discovery-based monitoring solution that's been around almost as long as Nagios. They're here at the conference, so I'm sure a lot of you have spoken to them. It's JVM-based, so it's pretty easy to get it deployed and running. In my experience, it runs fine with OpenJDK. Once you've tuned the discovery settings a little bit, it can pick up the state of a network quickly and provide a picture of where everything is running. One thing to note with OpenNMS and a lot of discovery-based tools is that the hosts being discovered have to respond to ICMP to be discovered. So it's less effective for finding rogue equipment on the network, and switch or router ACLs may limit the effectiveness of discovery in large distributed networks. OpenNMS uses SNMP to gather metrics and do local checks on monitored systems, and it makes it especially handy if you're managing a lot of network gear or a lot of kind of appliance-type devices like video conferencing systems and that sort of thing. There's a brand new project in the early stages of development called the Assimilation Project, and I think this one is really cool. It was started by Alan Robertson, whom you may know as the founder of the Linux HA project and a longtime maintainer of Heartbeat. It uses what he calls nanoprobes, or basically little agents that communicate state to a central data store, and these nanoprobes do distributed what he calls zero network footprint discovery, basically by listening to ARP traffic. This means that it can quickly discover your network topology even if your hosts don't respond to ping. And since the process is distributed and agent-based, it can discover complex and heterogeneous networks as long as the agents can connect back to the master server. Monitoring is also highly distributed and redundant. The agents all kind of monitor each other. So the loss of any one node will not result in the loss of monitoring for any other node. High availability is kind of built into the architecture. In a lot of ways, it represents a brand new paradigm in systems monitoring, and I'm probably not doing it justice here. But I really encourage you to check out the project website, and there are some good illustrations of the core concepts at play, and it will give you an inkling of the potential power of the software. So if total information awareness is your goal, or you just like messing around with bleeding edge technology, Assimilation should be on your list to check out. Xenos is another tool that does discovery. They were also here at the conference, so I'm sure a lot of you talked to them. Like OpenNMS, it also does time series monitoring and also has event handling capabilities. I get the impression that their community outreach team takes their job very seriously. So even though their main focus is a commercial enterprise product, the community version is OSS, and I think it's a viable solution. Zabbix is another product. I think it's very similar to Xenos that does network discovery. It also includes an agent that can be installed to monitor hosts and provides a system-level metrics. Again, OpenNMS achieves this through SNMP as a contrast. Zabbix is distributed by a commercial entity who offers support and consulting, but the software is all distributed under a GPL license. So there isn't an enterprise edition that's got more features. All right, now I want to highlight some projects that are focused on time series data. This category really started with MRTG, which I'm sure we all know and love, and later RRD tool. And they produced useful graphs, but were difficult to manage and don't really scale well, as we all know. Cacti came along in the early 2000s as a web configuration wrapper around RRD tool. It solved a lot of these use problems, but didn't really address the scalability of the RRD tool backend or the inherent scalability challenges of an SNMP polar-based graphing tool. Munin breaks through some of the polar-based scale challenges of an RRD tool-based solution by using an agent that gathers data locally and transmits it in batches to the central server. The master can also pass alerts to Nagios if the agents report threshold violations. Munin also breaks out of SNMP-based checks by making process and file system checks simple in the agent. Out of the box, the agent collects a ton of metrics, so it's a good way to get a comprehensive look at a single system, since it's quick and easy to deploy. On the downside, it's not known for super great performance, and the agent may be a bit heavy for some people's tastes. More recently, new projects have taken a more modularized approach, which has allowed for more mixing between visualization layers, storage layers, and data sources. The storage backends have become very free-form, allowing for the creation of arbitrary objects and key value pairs. And Graphite is a popular example of this. It's a framework that includes a storage engine similar in many ways to RRD tool, a daemon that listens for time series data, and a web-based visualization layer. It's notably different from Cacti and Munin because it doesn't include a polar. It listens for connections and passively accepts data, automatically creating new tables when new data sources connect. So provisioning new hosts is effortless. Lots of compatible tools have been created to feed it data, including SNMP polars. So if you have a more traditional setup, more traditional data sources, you can also accommodate it with Graphite. Here's a look at the graph composer in Graphite, which allows you to browse through all of your data points, combine them in a single graph, and apply filtering, aggregation, transformations, and so forth to the data. It's very powerful. And here's an example of a Graphite dashboard. It's super easy to compose dashboards of several graphs through the web interface. Very handy if you just need to whip something up together that you can show your executives or whatever. InfluxDB is a brand new project with a similar scope to Graphite. It's designed to be easily horizontally scalable, more so than Graphite, and its listener presents a standard HTTP API, making it a little easier to integrate than Graphite is. It also has an SQL-like query language with functions you can use to build complex graphs or new data sources. It's simple to install. It doesn't have any external dependencies. The project isn't calling itself production ready yet, but it should be soon, and it's definitely worth keeping an eye on. Prometheus is an internal project at SoundCloud that they open sourced just in January. It's another time series database similar to InfluxDB, but also has alerting functionality built in. It includes a polar, but is also capable of passively receiving data like Graphite or Influx. And notice, this new generation of tools is highly modular and composable. To some extent, you can mix the front ends and back ends, and some collection tools can be used with just about all of them. For example, CollectD. It runs as a lightweight daemon on monitored hosts, gathers metrics based on a built-in plugin library, and emits them at regular intervals to a destination that you configure. It's a great way to feed system statistics like CPU utilization and disk I/O into a time series database, and it can be managed easily by Puppet or Chef. StatsD is another example. It provides a TCP and UDP listener that can receive metrics in a simple format and forward them onto a backend like Graphite or InfluxDB. It's an easy way to add instrumentation to in-house software. Etsy released this, and it was inspired by a similar project that came out of Flickr. Grafana provides a visualization interface and dashboard composer that can be used with multiple backends, including Graphite and InfluxDB. It can embed annotations into time series graphs, can build dashboards that include data from different backend data stores. So if for some reason you're running both Graphite and Influx, you can build a single dashboard in Grafana. So as you can see, there's a lot of activity happening in this category, and these tools work great in elastic environments and DevOps workflows because the storage engines are so free-form. I think you can expect a lot of change and consolidation in this space over the next few years, but it's so easy to get value out of these projects quickly that I think it's worth doing some experimenting and trying new things out, even given that it's likely going to change in a couple of years. As a sidebar, you may have noticed that a lot of the more recent tools have switched from a polar model to a listener model. This makes so much sense with time series data, but I also think the model has application in functional monitoring. Polar-based monitoring is just inherently inefficient since so much of the TCP heavy lifting is concentrated in one place, and frequently the connection has to be held open while a check is run or a metric is sampled. Emitting events to a passive listener means more of the TCP work is distributed, and the check can be run locally and before the connection is open, so you only need to communicate long enough to send the data. In a managed environment, a lot of health checks can be run locally and problems emitted to Nagios or another event handler that scales better than polar-based solutions in many environments. So I have to expect we're going to start seeing more of it on the functional side. The assimilation project, which I mentioned before, has a fascinating approach to this as well. Again, I urge you to check it out on their website. Okay, on to our third category, which is event monitoring. And event monitoring and visualization is a fairly underdeveloped area, I think, in contrast to time series data, but it's one that's starting to heat up. For a long time, if you had limited resources and limited money, you were relying on hourly or daily runs of LogWatch to look for errors in system logs, or you were running programs like Logmon, which basically does a tail-F on one of your log files and emails alerts if it does a pattern match. Those are resource-intensive and clunky. Splunk came along in the early 2000s, offering an attractive centralized log analysis tool, but with a steep price that put it out of reach for most small shops that produce a lot of log data. I've certainly never worked anywhere that can afford it. Another open source log management tools have been produced, like PHP syslog NG, but they use relational data stores like MySQL as the back end, and those data stores struggle with log data, and the results were poor search performance and poor scalability. PHP syslog NG has been rewritten as Logzilla, by the way, and is now an exclusively commercial product. Recent advances in open source data stores like Elasticsearch have given rise to Logstash, which provides very similar functionality to Splunk with a completely open source stack. This is commonly referred to as the ELK stack, comprised of Elasticsearch for the backend data store, Logstash to receive and process log events, and then pass them to the storage backends, and Kibana, the web-based visualization layer that makes it easy to create dashboards of your log data, including histograms and pie charts and that sort of thing. As of 2013, Elasticsearch is the commercial keeper and distributor of the ELK stack components. It's all OSS, but like a lot of companies, they offer support and consulting services. So here's a screenshot of the Kibana part of the ELK stack. As you can see, it provides not only ways of examining your log data, but lots of cool ways of visualizing it with histograms, pie charts, and bar charts, and so on. Last fall, Nagios announced the Nagios log server, which is a commercialized version of the ELK stack with multi-server user security features and integration with Nagios built in, and it kind of promises easy to deploy clustering, which is something that's a little challenging today with Elasticsearch. There's no free version, but it might be a way to get ELK in the door if you have a manager that frets about software without support, or you simply don't have time to invest in getting an Elasticsearch cluster running. Graylog 2 is a product very similar to the ELK stack, and it's getting close to a 1.0 release. Similar to Elasticsearch, Graylog Incorporated releases all of their code as open source and offers production and development support contracts. It has external dependencies on MongoDB and Elasticsearch, so very similar to the ELK stack. I expect to see the event management tool space heat up like time series has, even as the two categories start to see more overlap. And again, I think it'll be a while before a clear overall winner emerges in terms of storage backends and visualization layers and event handlers and so on. But what's out there today has plenty of value to offer, and if you're not running Logstash or Graylog 2 today, you owe it to yourself to get it going. Chances are you won't have to wait long to see a real benefit from it. So our categories again. That's a very quick summary of our three major categories. And if I left your favorite project out, let me know afterwards, and I'll probably want to hear about it. Now, as I said at the start, there's a lot of overlap between the functionality of the tools in these three categories, and some of the tools I mentioned could fit in multiple categories. It could be tempting to look for a single solution that captures all of this functionality, and several projects and companies are aiming at a unified solution. OpenNMS, Zabbix, Xenos don't just do discovery and monitoring, they also graph time series data and have asset management and network management functionality built in. NetE is a similar project. They're still kind of defining their commercial and release model, and for now it's really kind of mainly defined by a long list of external dependencies. And Nagios Enterprise is in the process of building a suite of commercial products around Nagios that's comprised of a lot of different components, like Nagios Log Server, but at least it gives you a single neck to choke for support, I guess. Some of these all-in-one products and suites of products can be very attractive, and if you find one that meets all your needs, then it can save you a lot of time you might otherwise spend composing a monitoring infrastructure out of individual parts. For a lot of shops that operate at a smaller scale, but otherwise have more enterprise-like requirements, or in other words, the primary business isn't technology, it may be a wise approach to look for a single product that can do everything, and even adapt your workflow to the tool if you need to a little bit. I think for shops doing DevOps methodologies and managing infrastructure as code, especially those working in elastic environments where architectures and requirements can change over time, there's tremendous opportunity to combine the latest generation of modular tools in ways that were difficult or impossible just a few years ago and produce business value quickly. If you find that one of the monolithic products works for you in that sort of environment, then great, but it's probable that a mixture of smaller components will address your specific needs more easily. For a few years now, Jason Dixon, who organizes the Monitorama conference, that's going to be in Portland this year, has described the event stream paradigm in monitoring. And rather than try and reproduce his diagram, I've just shamelessly swiped it from one of his slide decks. It goes like this. Events enter the tool chain. Depending on type and content, they might get sent to a storage backend for visualization or aggregated with other events before getting stored. Depending on content, it might change state in a state engine, trigger an event handler or an alerting process, fire off an email or a VictorOps alert or something like that. By using small, composable tools in combination, you create the event stream that suits your technology stack and your environment. That doesn't mean necessarily turning your back on institutional knowledge and established tools. Nagios can sit comfortably right in the middle of the event stream. Isinga 2 was designed with modularity in mind and has built-in support for sending metric data to Graphite, for example. You can do this with Nagios as well, it's just not quite as easily. Sensu, Shinken, Monet Collecti, they're all potential components in a modular monitoring tool chain. You can pick the pieces that work best to meet your particular needs and combine them in a way that they lend value to each other rather than kind of creating a bunch of islands of data that you have to correlate manually later. The current generation of open source monitoring tools is giving us easier access to deep insight, better visibility into faults, and amazing interoperability. These solutions are quickly becoming critical sources of not just operational and developmental intelligence, but of business intelligence that has value outside of technical departments. This helps DevOps, and IT teams more effectively communicate their overall value and makes life easier through managing high-demand 24/7 platforms. The technology is moving way too fast for enterprise solutions to keep pace, meaning that as a user of open-source monitoring solutions, finally, you don't have to wonder what you're missing out on from the commercial products. Open source is now the vanguard of monitoring and telemetry software development, and it's a great time to be involved. And if you have any questions, I'd love to answer them now. Yeah? Yeah, let me... In other words, you will get ephemeral spikes. Mm-hmm. Then trigger the Mhm.
Okay, well, if you can capture that in the tool, you avoid a false alert. Or if you have a gradual drift, you're looking more at a capacity planning issue rather than a performance problem.
Uh, so the question was about kind of ephemeral spikes in metric data, like say a transient CPU spike that might trigger an alert in a threshold-based monitoring solution like Nagios, but by the time you go and look at everything, everything's been kind of recovered. I kind of get around solutions or problems like that myself in Nagios in particular. If I know something is kind of prone to producing ephemeral spikes, you can certainly change the check so that it has to fail several times before it triggers an alert. But kind of going back to the modular topic, I think time series monitoring is really what's going to kind of make it possible to, first of all, capture the trend and show the long-term trend for capacity planning purposes, but then also allow you to kind of alert on averages crossing a threshold rather than spikes crossing a threshold. Yeah.
Is this something you recommend for that distributed monitoring?
Distributed monitoring?
Yes, something that goes in the containers. Basically, I can spin up like multiple instances of any monitoring solution, and I can monitor. Depending upon like different polos, different data center, different
A lot of the products that I talked about are kind of capable of working in that way. If you've got sort of time to invest in it, Nagios can be made to work in that way. I think that again, a lot of the newer, more composable products like Sensu probably lend themselves more easily to that kind of distributed environment. And again, I think the assimilation project is going to be the place to look and see where that's going in the long term, because I think they're really kind of built around that idea of large distributed heterogeneous networks.
And one more question. Do you recommend something like for the alerting thing for based on the graphite or InfluxDB? Because I know they basically collect the time series data, but then if I see something like any unusual event, can they trigger like some solution that is based on the graphite, or maybe like it can trigger an alert or something?
The question was alerting based on events coming in, basically. And if I'm understanding your question correctly.
For example, like I'm collecting the stats, you collect D or set D or
Mm-hmm.
ganglia or whatever. I'm basically have ganglia as my backend, or sorry, like graphite as my backend to collect all the time series data on
Mm-hmm.
the matrices. Is there any solution for the alerting based on them? Based on graphite, basically.
Yes, there is. Dan, what is Jeff's project called? Rearview is a project that one of our engineers at VictorOps worked on at his previous job. I don't know what the release status of it, if it's available out there, but it's designed specifically to look at your time series data in graphite and alert if it crosses a threshold. But Prometheus, which is another of the time series products out there, has that functionality built into it. And I honestly expect to see pretty much all of those time series products integrate that kind of functionality. Any other questions? Yeah.
What are these monitoring tools more focused on monitoring services like MySQL and response time, or is it web services? So who's tracking web server response time kind of thing, and it gets beyond it. So would that be something we have to customize?
No, not necessarily. That's kind of if you wanted to. Well, I guess most of the functional monitoring products do a lot of what you're talking about there. And like I said, the Nagios ecosystem has a plugin that will do kind of basically anything. Like I know Percona released a set of Nagios plugins that can do a lot of deep checking into MySQL and can alert on things like if your replication slaves get out of sync with your master and that sort of thing. And most Nagios plugins can also kind of alert on kind of a variety of different thresholds. So you can certainly alert based on an HTTP socket taking too long to respond or something like that. And again, I think time series data monitoring is going to pick up a lot of slack in that area as well once you start kind of graphing that data constantly. And that goes back to the earlier question about detecting the difference between a transient spike and an average crossing a threshold. Yeah.
What about the
Inventory
inventory check?
checks, like in terms of
Hard drive,
kind of a asset management sort of thing. I'm going to be honest and say that I don't have a lot of direct knowledge in that area. I think that Zabbix and Xenos and OpenNMS tools have at least some of that functionality built in, and certainly I think Monet does a lot of kind of local discovery of what sort of devices and daemons are running and that sort of thing. Yeah.
Would love to hear any war stories about business intelligence gathered from this kind of data
Oh boy. So war stories of business intelligence gathered, and I'm naturally drawing a complete blank now that I'm standing in front of a room full of people. But certainly, at VictorOps, we're not a monitoring company, but we're very monitoring focused, and so we have, essentially all of this stuff running in some capacity or another, and we've, every day solve problems in unexpected ways just by kind of looking at a graph and saying, that's kind of unusual, and that's, I think, there's been kind of a monitor all the things movement, lately, because it's become very easy to monitor all the things, and it's tempting to do. It's also kind of scary to do because you can kind of bury yourself in an avalanche of data. But that's why I like integrating things so much and kind of creating combined dashboards and such. So you can sort of have this wilderness of data, and you can kind of look at a big thing of graphs, and it gives you the opportunity to kind of spot that little dot somewhere that's going to tell you something that you weren't necessarily looking for. I guess the best advice is just to be open to the opportunity to learn things from the tools that you weren't expecting to learn. Any other questions? Well, again, thank you so much for hanging around until the very end. Thanks very much.